Hi, I'm Amanda Jones, and in this video, I'm going to be walking through how to construct a binomial distribution as well as graph a binomial distribution in Excel. Now, you might be wondering, I have a textbook with the binomial distribution. Why do I need this? Well, our textbook and many textbooks include binomial distributions, but they don't go up very far. I think ours stops at 20 and it has a few skips in between, especially between 15 and 20 for the n, or the number of trials that you are performing in your experiment, your binomial experiment. And then we also have our p's rounded to 3 decimal places. And so if you want a p that is out to more decimal places, you're limited by that table, and you would have to either use the formula or use a software to see that. So I'm going to show this in Excel, and hopefully it'll help you with the binomial distribution. The first thing I'm going to do is set my n and my p. I am using terminology from the textbook that I teach out of, but I will also try to reference what in words it is. N is our number of trials. So we call that n, number of trials. And then p is the probability of a success. And this is the probability of a success in a single trial, one trial. So I'm just labeling those n equals p equals. And then over here in my A and B column, my first two columns, I'm going to have my R. And R is the number of successes. And then I'll also have my probability of R, my P of R, the probability of a success. So I'll put that label there. Let's start with an n of 20, and I want to start with 20 because I want you to be able to go to your table and see that this is the same as the binomial distribution table in your textbook. And so we'll start there, and then I'll expand it up to some other larger numbers. Let's also start with a p of 0.5, okay? Right in the middle. And so I'm going to list all my possible r's. If my n is 20, then I start with 0 successes. And don't forget to start with 0. We always want to look at the probability of no successes. That is an option. Remember that you can click and drag in Excel and it'll repeat the pattern. So I've got this to 20. And then I'm going to call the formula. In Excel, the binomial formula is binom, B-I-N-O-M, .dist. You see it pop up there, D-I-S-T. And then those parentheses. And then they tell you what they want you to input into that formula. They call the first value the number underscore S. That's the number of successes. We're calling that R. So the number S, or the number of successes, is R. So I'm just going to click on that cell to reference that R. I'm not going to freeze it because that's the thing that's going to change as I pull that formula down. The next thing they ask is the number of trials. That's our N. So I'm going to click on the 20. I am going to put dollar signs around that cell reference because I want to freeze that cell. I always want N to be 20. I don't want that to drag as I drag the formula down. The next thing they want is the probability. They have underscore S. This is the probability of a success. That's what we are calling P. So I'm going to reference that cell. Same thing here, dollar signs around it so that when I drag, it is frozen. And then the final thing they ask for is cumulative or not. And so we do not want a cumulative distribution. We are going to enter in false. A cumulative distribution would accumulate as it moves down. And so that way, if you looked, for example, at r equals 4, it would be the probability of 4 or less successes, which is not usually what you want in the binomial when you're using a binomial. Typically, when you want to look at r equals 4, you want exactly 4 successes. And so that's why we don't use a cumulative very often. But in the case that you ever want it, that's how you do it. All right, so there is this formula, or this value. This is the probability of 0 successes when we have 20 trials, and the probability of a success in those trials is 50%, or 1/2, or 0.5. You can see that this is written with an E in it and that -0.07. This is scientific notation. It's a very, very small probability. So it would be 0.7 zeros and then 953. And so you can see that you have this accuracy in Excel that you don't get with a table that you find in a textbook. I want to just complete this distribution. So I'm going to click that right hand bottom right and drag. And that just copies that formula all the way down, changing the R because that's the only thing it didn't freeze. And so you can see these probabilities come up, and you can compare these to the table in your book if you have an n equals 20 and a p of 0.5. Okay. Let's graph this so we can visually see this representation. I'm going to do this with a bar graph. And so I'm going to highlight these probabilities and insert just a bar graph here. So there's that. And now you can see that visual representation of the binomial distribution for an n of 20 and a p of 0.5. You can see that the mean is right here in the center, and we actually need to change this x-axis labels. It starts at 1, and we need it to start at 0 to mimic our r. So let me do that. To do that, I'm going to click on that x-axis. I'm going to right-click and select data. And then under the horizontal axis labels, I'm going to click this button so that I can reference it in my chart here. And I will click and drag on my R's, hit enter, and then OK. And there you go. You see that change. So that's how you can change those labels on a bar graph, is you can reference them in your horizontal axis labels. So now it's labeled correctly. Let me also add the axes titles. So the horizontal axis, this is what's graphing our R values. So I will put number of successes because that's what R represents, and parentheses R, and then I will change the y-axis, which is the vertical axis title, to the probability of a success. Okay, and it's P of R. All right, so now those are labeled correctly. And we've got our graph there. Let me title it just binomial distribution here. I usually would be a little bit more exact with my graph title, but in this case, I'm going to be changing n and p. Usually I would include what n is and what p is, but I'm going to be changing them and looking at the graph a little bit. So let's do that. Let's kick our n up to 30 and see what happens. Of course, our graph is not going to go up to 30. Our r's are not to 30, so let's change that. Let's keep on pulling them up to 30. I want you to see how simple this is. I don't want you to be scared of large numbers for this distribution. So just that simple. Just dragged a little bit more, a little bit longer. That's all you need to do. And then you can click on your graph and pull these references for the graph down to include all the way to 30. Okay, so there it is to 30. And then I'm going to stretch it out a little bit so you can see a little bit better. When you get a bigger number, you might need to widen that graph to see it a little bit better. Okay, then let's see what happens as we shift P. So let's look at a P of 0.3 and see what happens. Now our mean is going to change because the mean is n times P, so now it is 9. And you can see that peak at 9. We are skewed right when P is less than 0.5. And then let's change it to something that is above 0.5. Let's look at 0.8. Okay, and you can see that shift to the other side. So now your mean is 30 times 0.8, and you're skewed left. And so you can see what happens as you change P. Of course, 0.5 gets that graph right in the center. And then, you can change it. Again, this is another thing that's nice about the Excel versus just looking in the table, I could change P to something like 0.65, which is not something typically on the table. We usually have those multiples of 0.1. So you can do that as well, or even like 0.125. Okay, so you can do that in Excel and see those shifts and those changes. And of course, all this is shifting and changing as well. So you're going to be able to get those values. If you wanted, for instance, to see what's the probability of at most 4 successes here, so 4 or less, then I could just highlight those values. This is at most 4, so 4 or less. And then down here is the sum of those values. So that would be my probability. And I've got it at 0.6812. And it's a really great representation because it is adding with all these decimal points on there. I hope this was helpful for you. I hope that it helps you understand the binomial distribution a little bit better because of that visual representation. And I hope that it gives you a tool as you are using it to compute some probabilities.